Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So we have a separation of 23 centimeters, or we can say 0.23 meters. We also have a Q sub 1 of positive 3.5 microcoulombs, or we can say 3.5 times 10 to the negative 6 coulombs. Now, Q sub 2 is going to be equal to negative 7.2 microcoulombs. This will be negative 7.2 times 10 to the negative 6 coulombs. And so at the mid, they want us to evaluate the electric potential and the electric field at the midpoint, so specifically at the midpoint. So the electric potential at mid would be equal to KQ sub 1 divided by D divided by 2, and then we'll have plus KQ sub 2 divided by D divided by 2. This is going to equal to K over D Q1 plus Q2. Now again, we're having the distance because we're trying to evaluate this at the midpoint, and then for the numerator, we'll just use K. So K is for Coulomb's constant, and then times, of course, the charge. So this would be for the electric potential at the midpoint, and we can solve. So this would be 2 times 8.99 times 10 to the 9th divided by D. In this case, D is going to be 0.23, and then it'll be times 3.5 minus 7.2 times 10 to the negative 6. 0.23, and then we'll have, as tiny as I can write it, minus 7.2, 10 to the negative 6th. So at this point, we can say that the V mid is going to be equal to negative 2.9 times 10 to the 5th volts. And this makes sense, it's negative, because this will be your answer part A, by the way. But it makes sense it's negative because this term makes it negative. 3.5 minus 7.2, that's going to end up being a negative number, and that's going to carry through. It's going to carry through throughout the entire equation. So again, the voltage or the electric potential at the midpoint is going to be negative 2.9 times 10 to the 5th volts. Your answer for part B is going to be the magnitude of the electric field at the midpoint, and this is going to be Q1 over D over 2 squared. However, here it's going to be plus K, the absolute value of the second charge, divided by, again, D over 2 squared. So we find that this is going to be equal to 4K divided by D squared, and then Q1 minus Q2. So this is going to be, of course, higher. So this would be E mid would be equal to 4, and then times 8.99 times 10 to the 9th. And then this would be 3.5 plus 7.2 times 10 to the negative 6th. All divided by 0.23, and then this separation is squared. So the electric field at the midpoint is going to be equal to 7.3 times 10 to the 6th volts per meter. So this would be your answer for part B. That is the end of the solution. Thank you for watching.